dV by dt triggering method. Just now I explained about what exactly gate triggering, temperature triggering and light triggering methods. The continuation of this is another method of triggering is dV by dt triggering. The idea behind existing dV by dt triggering is how it is exist in SCR means we know that if the SCR is under forward blocking mode, we know that if the SCR is under forward blocking mode, J1, this is J1, this is J2 and this is J3. Three junctions, J1, J2 and J3. Three junctions. The SCR is under forward blocking mode. J1, J2 and J3 are the three junctions. Okay. J1 is closed. J3 is closed. J1 junction is closed means it acts as a one conducting medium, conducting plate. Let. J3 junction is closed means it acts as another conducting plate. J2 junction is open means it acts as one dielectric medium. That means two conducting plates are separated by one dielectric medium. That's the reason why under forward blocking mode, SCR equivalent to the capacitor. SCR is equivalent to capacitor. Because of this property, we are telling that there exists a dV by dt triggering. That means under forward blocking mode, under forward blocking mode, SCR is equivalent to capacitor. SCR is equivalent to capacitor. Reason is this one. Now, once it acts as a capacitor, we know that property of capacitor. No? Capacitor cannot allow sudden change of voltages. Means suddenly capacitor acts as a short circuit. For example, this is SCR. Initially SCR is under forward blocking mode. Under forward blocking mode, SCR acts as a capacitor. Under forward blocking mode, SCR acts as a one capacitor. Then we are applying the forward voltage. If the suddenly switch is closed, suddenly capacitor acts as a short circuit. When suddenly capacitor acts as a short circuit, it starts the conduction. Yes, that's the reason why. That means under forward blocking mode, SCR equivalent to capacitor. SCR is equivalent to capacitor means let the current at J2 junction is I2. Shall we write like this? I2 equal to capacitance C2 into dV by dt or Cj. That is the junction capacitance Cj into dV by dt. If dV by dt is increases, what is the current at J2 junction? Current at J2 junction increases. Then charge at J2 junction increases. If the charge at J2 junction is increases, what is the width of J2? Width of J2 reduces. When the width of the J2 is reduces, at a given forward voltage, then J2 is breakdown. At a given forward voltage, J2 is breakdown. J2 is breakdown, and SCR comes into forward conduction mode. This what exactly dV by dt triggering method. But don't think like this. We are not applying sudden change. We are not applying any sudden change of voltages. Sudden change of voltages or dV by dt is inherent process. Understood? If you want to turn on the SCR, that's why you want to apply sudden change of voltage, then you want to bring the SCR into conduction mode. It is not a manual process. We are not doing that one. Inherently it is happening. That's why dV by dt triggering is also one of the inherent process. We are not doing intentionally. It is an inherent process. That's why dV by dt triggering causes unwanted triggering of SCR. What is the purpose of implementing thyristor? You want to make turn on is in our hand. Whenever you want to trigger the SCR, according to that we can trigger, we make the conduction. That is the semi-control purpose we are implementing. Without giving triggering, if any sudden change of voltages are there, suddenly it starts the conduction. Is there in your hand? For control of SCR is in our hand? No. That's why dV by dt triggering is the inherent process and it causes unwanted triggering of SCR. Hence, practically, to eliminate this dV by dt or unwanted triggering of SCR, we can use some protection circuits, all these. That is nothing but a snubber circuit we can use. What exactly is snubber circuit, how we can design this snubber circuit, all this concept later on we will see. That's why the point to remember, dV by dt triggering is also one of the inherent process. dV by dt triggering. dV by dt triggering is a inherent process. Why this dV by dt triggering exists? Why this dV by dt triggering exists? Yes, under forward blocking mode, SCR acting as a one capacitor. If the suddenly switch is closed, because of that capacitor property, dV by dt triggering is exists. Okay, that's why dV by dt triggering is a inherent process. Inherent process causes unwanted triggering. Unwanted triggering. Unwanted triggering. Hence, this method is not allowed practically. This method is not allowed practically. Using some protecting circuits, that is one of the protecting circuit which cannot allow the dV by dt is snubber circuit. By using the snubber circuit, we cannot allow the sudden change of voltages across the SCR. Then it cannot trigger. Understood? Okay, this is about what exactly dV by dt triggering of a SCR. Okay, this clear? This about different turn-on methods of SCR. In this concept, I discussed what exactly forward voltage triggering method, and I explained about two transistor analysis. Then from the two transistor analysis, I explained two concepts. What exactly that is gate triggering method and temperature triggering method. Then temperature triggering is also one of the inherent process. Practically you cannot allow. Light triggering method. Then light triggering is also controlled process. That light triggering is mainly used in HVDC converter. Then dV by dt triggering is also one of the inherent process, but practically this method is not allowed. How you cannot allow the dV by dt triggering means by using the snubber circuit arrangements. Then in this I want to write some important notes that you concentrate. Okay. Some note you remember. One is, tell me, among all these triggering methods, which method is more preferable? Gate triggering. Among all the triggering methods, among all the triggering methods, among all the Triggering methods. Triggering methods. Gate triggering is more preferable. Gate triggering is more preferable. This one important note that you concentrate, write down parallelly. Gate triggering is more preferable. Among all the triggering methods, gate triggering is more preferable. Okay. Light triggering is used in HVDC converters. Light triggering is used in HVDC converters. HVDC converters. Third one. Only in gate triggering only gate supply is connected. In gate triggering only gate supply is connected. In remaining triggering method, without gate supply, SCR will be turned on. Okay. Only in gate triggering, gate supply is connected. Gate supply is connected. Okay. In remaining triggering methods, okay, no need of gate supply. In remaining triggering methods, no need of gate supply. Okay. Then among all the triggering methods, which is more preferable? Gate triggering. Light triggering is used in HVDC converter. Only in gate triggering only gate supply is connected. In remaining triggering methods, the another point to remember based on this concept, under forward blocking mode, SCR is equivalent to capacitor. SCR is equivalent to capacitor. Fifth observation. In the above all triggering methods, thyristor is turned on or SCR is turned on by controlling the charge at J2 junction. Hence, SCR is a charge controlled or current controlled device. SCR is a charge controlled or current controlled device. Because the SCR is turned on by controlling the charge at J2 junction. That's why it is treated as a charge controlled or current controlled device. Yes. The another point to remember. Okay. For example, here I am giving one simple example. Let under forward blocking mode, SCR offers a capacitance of 20 microfarads. Okay. And leakage current is 10 milliamperes. If a capacitance of 10 microfarad is connected across SCR, then dV by dt is dash. If the question is framed like, just example I am giving, based on this concept. Under forward blocking mode, SCR offers a capacitance of 20 microfarads and leakage current is 10 milliampere. Under forward blocking mode, which current is exists through the SCR? Leakage current only. And if a capacitance of 10 microfarad is connected across SCR, then dV by dt is dash. We know this. Then what is the solution for this problem? If a capacitance is, SCR offers a capacitance of, this is SCR is under forward blocking mode, acts as a one capacitor, then this is 20 microfarad. Then a capacitance of 10 microfarad is connected across the SCR. Then what is the leakage current in the SCR? Is equal to 10 milliamperes. Okay, then dV by dt. Then we know that leakage current IC equal to or IL equal to C into Cj into dV by dt. Na? C equivalent you take. C equivalent into dV by dt. Na? This is how much? 10 milliampere. C equivalent means two capacitors are in parallel. If the two capacitors are in parallel, the resultant capacitance 30 microfarad, 30 into 10 to the power of minus 6 dV by dt. This is how much? 1 by 3 into 10 to the power of minus 3 by 10 power minus 6 dV by dt. Then how much dV by dt you can get? dV by dt you can get. How much? dV by dt you can get. Then 0.33 volts per millisecond. 0.33 volts per millisecond. Like this we can calculate. If problem is framed, that's small concept I am discussing. Okay. With this, turn-on method and two transistor analysis of SCR is completed. This one concept in thyristor. The starting I given characteristics and modes of operation. The second concept I am explained turn-on method and two transistor analysis of SCR. The another concept in thyristor is then very important concept for all the competitive point of view. That concept, based on that concept, questions are framed. That is nothing but a dynamic characteristics or switching characteristics or turn on and turn off mechanism of SCR. This also very important concept of that. All these concepts comes under thyristor only. Clear? Then you go for next concept. Please concentrate. The next concept in thyristor is that concentrate dynamic characteristics. Dynamic characteristics. Dynamic characteristics. Dynamic characteristics are switching characteristics of SCR or switching characteristics. Switching characteristics or switching characteristics of SCR. Or this is also called turn on and turn off mechanism of SCR. This concept comes under turn on and turn off mechanism of SCR. Turn on mechanism and turn off mechanism. Okay. Turn on methods are different, turn on mechanism is different. Turn on mechanism is nothing but that is turn on characteristics. Turn off mechanism is nothing but that is turn off characteristics. Okay, that you want to draw the turn on characteristics and turn off. In dynamic characteristics, again we have two types of characteristics that I want to discuss. One is turn on characteristics of SCR, that is turn on characteristics of SCR. Another one is turn off characteristics of SCR. Okay, turn off characteristics of SCR. Turn off characteristics of SCR. Turn on and turn off characteristics of SCR. First you concentrate on turn on characteristics of SCR. Okay, turn on characteristics of SCR. Okay, characteristics of SCR. This turn on characteristics of SCR. We know that. What do you mean by turn on? Turn on of SCR is nothing but the process of bringing the SCR from the forward blocking mode to forward conduction mode. The process of bringing the SCR from the forward blocking mode to forward conduction mode is called turn on of SCR. The process of bringing the SCR from the forward blocking mode to forward conduction mode is called turn on. Then what is the significance of turn on characteristics? The turn on characteristics explains how the current through the SCR is changing from 0 to rated current, and how the voltage across the SCR is falling from rated to 0 voltage or on state voltage drop. I told already, turn on is nothing but a current rising. That is, the current through the SCR is rising and voltage across the SCR is falling. Turn on is nothing but a current through the SCR is rising and voltage across the SCR is falling. Then this turn on characteristics explains how the current through the SCR is changing, how the voltage across the SCR is falling during turn on. That is the significance. Static VI characteristics explains modes of operation, but dynamic characteristics explains turn on and turn off characteristics. What is the significance of turn on characteristics? That during turn on of SCR, during change of SCR from the forward blocking mode to forward conduction mode, how the current through the SCR is changing, how the voltage across the SCR is changing, all these are explained by using turn on characteristics. Clear? First, I want to draw the total turn on characteristics of SCR. Then I will explain what is the significance of each characteristics. Okay. First, you list out what is the turn on characteristics of a SCR. From that, I want to list out the significance of each time. Okay. This is the total turn on characteristics of a SCR. You list out these characteristics. This is the total turn on characteristics of a SCR. Okay. This is gate current waveform, IC. This gate current. This IC gate current. Okay. And this one is 0.9 IC. Parallelly, you draw these characteristics, list out these characteristics. 0.9 IC. Okay. This is anode current waveform. This axis is time axis. This is time axis. Okay. This is anode current waveform. This is anode current. This is anode current waveform. And this is which waveform? Gate current waveform. Gate current waveform. Then during turn on of SCR, the current through the SCR is changing like this. Yes, sorry. Go through this characteristics. This is anode current waveform. And this is anode voltage waveform. This also I taken in time axis. Okay. Okay. This is anode voltage waveform. Okay, this is take this is 0.1 VA. Waveform is anode voltage. Yes, this is VA anode voltage. This is 0.9 VA. This is 0.1 VA. Yes, this voltage is on state voltage drop or forward voltage drop. On state voltage drop. This anode voltage waveform. This current is anode current waveform. This is IA. This is anode current waveform. This is IA. This 0.9 IA. This 0.1 IA. But this current is anode current. It's IA waveform. This gate current waveform, anode current waveform, anode voltage waveform. I told turn on is nothing but a current rising, voltage falling. The current through the SCR is rising. The voltage across SCR is falling. Then you take this total time is nothing but a turn on time. This total time is nothing but a turn on time. Okay. This time is called delay time TD. This time is called rise time TR. This time is called spread time TS. This is delay time, rise time and spread time. The total turn on time is equal to delay time plus rise time plus spread time. Then what is the total turn on time of SCR? This okay na? Now let's see. What is the total turn on time of SCR? Okay. This I am explaining the turn on characteristics now. I am explaining turn on characteristics. In this turn on time equal to what is the total turn on time of SCR? Turn on time. T on equal to TD plus TR plus TS. That is TD is delay time. TD is delay time. What is TR? Rise time. TR is rise time. What is TS? TS is spread time. TS is spread time. Okay. Now what is the significance of each time and what is the definition of the each time that I want to discuss. First we will start with the delay time TD. A delay time TD. What is the delay time TD? First, I want to make definition. We can define with respect to current or with respect to voltage. The delay time is defined with respect to current or with respect to voltage. With respect to current means rise of current. With respect to voltage means fall of voltage. Now see, with respect to current, it is the time between at the instant of 90% Ig to 10% of Ia. I taken the reference is gate current, but I am not taken the reference is anode current. But if you want to take with respect to anode current means you take this current is 0 anode current. But it is meaningless. If the gate current is reaches to 90% of Ig means, but there must be some anode current, but it is not measurable. That's the reason why in the definition of delay time with respect to current, I taken the reference is gate current, not anode current. That means how to define delay time is, it is the time between, it is the time between, it is the time between, it is the time between at the instant of, at the instant of, at the instant of 90% Ig to 90% Ig to 10% Ia. That is 0.1 Ia. Or we also define with respect to voltage. With respect to current means increase of current. With respect to voltage means fall of voltage, because it is a turn on transition. Okay. Now, how to define delay time with respect to voltage? It is the time between at the instant of, or it is the time between 100% Va to 90% Va. It is the time taken fall of voltage 100% Va to 90% Va. That is, it is time between, it is time between, it is time between 100% Va to 90% Va. This is what is the definition of the delay time. Another point you remember, during delay time, anode current is very small, associated with a small area. It is very small current associated with a small area. That means, during delay time, current is very small associated with a small area. Because very small current, in the total SCR, the current is started just now only, current is very small associated with a small area. In small area, small current is flowing means there is no effect of SCR. The SCR is properly working. Understood? That's why during delay time, current is very small. Current is very small. Current is very small. Associated with a small area. Associated with a small area. Current is very small, associated with a small area. Yes. The another point you remember here. The another point you remember. Concentrate. During delay time or by controlling gate current, only delay time is controlled, but TR and TS is unaffected. Very important observation, already framed in competitive. By controlling gate current, we can control only delay time. But I told now, once SCR starts the conduction, gate losses its control over anode current, then we cannot control. But concept is here, during delay time, current is very small because just current, the thyristor not started the conduction. That's the reason why by controlling gate current, only delay time is controlled. By controlling gate current, by controlling gate current, only delay time is controlled. Only delay time is controlled. Only delay time is controlled. But TR and TS is unaffected. TR and TS is unaffected. TR and TS is unaffected. Okay. That is, if IG is increases, gate current is increases, TD is reduces, TR and TS unchanged, TR and TS unchanged, and TR is what happened? Even though TR and TS is unchanged, if TD is reduces, what is the turn on time? Then turn on time is reduced. Okay. And this is the observations from the delay time. Concentrate, what is the definition? Current is very small, associated with a small area, and only by controlling gate current we can control the delay time. But TR and TS is unaffected. And this is the observations from the delay time. Clear? Okay. Every point is important for all the competitive point of view. Once you are solving the previous GATE or IES or any PSUs questions, already questions are framed based on these points. Every point is important. Okay, this what exactly delay time of SCR. Then I want to explain what is the rise time, that you concentrate. This clear? Okay. That we will see what is the rise time. What is the rise time of SCR? Rise time TR. First I want to write definition. Again we can define with respect to voltage and current. With respect to current means rise of current. With respect to voltage means fall of voltage. One definition is with respect to current. It is time between 10% IA to 90% IA. Or with respect to voltage means it is time between 90% VA to 10% VA. This is 10% IA to 90% IA. 90% VA to 10% VA. This time is taken as rise time. Very important observation. Concentrate. During rise time, there exists a sudden change of current. During delay time, current is very small, associated with a small area. But whenever time is enter into the rise time, there is a large di by dt. Because of large di by dt, high current associated with a small area. If the high current associated with a small area, there is high current density. Yes or no? How to define current density? J equal to I by A. Na? Small area, high current density. Because of high current density, a large hotspots are appear or local heating is appear, due to that SCR may be damaged. Hence, during rise time, you must limit the di by dt. Understood? That means, during rise time, because of large di by dt, a high current associated with a small area, associated with small area, it causes local heating or hotspots. And SCR may be damaged, and SCR may be damaged. Because during delay time, current is very small associated with small area. Whenever time is entered into the rise time, there is a sudden rise of current. This sudden rise of current takes place from small area itself or large area itself? Small area itself, because initially very small area, small current, but suddenly current is rising. The rise of current takes place from small area only. In small area, high current means heating effect. For example, in 10 ampere wire, if you allow the 100 amperes, then total it will be heated. Wire will be heated. No? That is a problem. That's why during rise time, you must limit di by dt. That is during rise time. During rise time, we must limit di by dt. We must limit di by dt. For that, what you can do? What you can connect? The device which cannot allow the sudden change of current, the element which cannot allow the sudden change of current, that element is connected. Then which element cannot allow the sudden change of current? Inductor cannot allow the sudden change of current. That you know the properties of inductor and capacitor that you studied in the fundamentals. Initially, inductor acts as a open circuit. During rise time, you must limit dy by dt. For that, an inductor is connected. An inductor is connected in series with SCR. In series with SCR. In series with SCR. But what is the problem with the inductor, you tell me? No doubt at all. Inductor cannot allow the sudden change of current. Then SCR is protected. But problem with inductor is always inductor opposes the rise of current. When the inductor opposes the rise of current means for rise of current it takes more time or less time? More time. If the rise time is increases, what the turn on time is also increases. That's why for turn on of SCR it takes more time. Hence, practically, instead of inductor, saturable reactor is more preferable. It also cannot allow the sudden change of current. Saturable reactor also cannot allow the sudden change of current. But the property difference between the inductor and saturable reactor is, once the saturable reactor is saturated, the reactance offered by the reactor is 0. When the reactance offered by the saturable reactor is 0, there is no opposition, then current easily rises. Then rise time is reduces, turn on time is also reduces. Within less time, the thyristor will be turned on. Clear? No doubt at all. Inductor cannot allow sudden change of current, it protects. Even saturable reactor also cannot allow sudden change of current, it also protects. But the difference between inductor and saturable reactor is, inductor always opposes rise of current. Actually, when the protection is required? During sudden change only. Okay, but after that no need of protection. But even saturable reactor also cannot allow sudden change of current. But the difference is, always inductor opposes the rise of current. Then rise time will be increases, it takes more time for turn on of SCR. Hence, instead of inductor, saturable reactor is more preferable. That is, inductor always opposes the rise of current. Inductor always opposes the rise of current. Opposes the rise of current. Opposes the rise of current. Hence, practically, saturable reactor is preferable. Saturable reactor is preferable. Saturable reactor is preferable. The reason I told, saturable reactor is preferable. Clear? This about what is the observations from the rise time. The another point to remember, during rise time only, during turn on process, during rise time only, power losses are high. Power losses are high. During rise time only, power losses are high. Because during rise time, high current associated with high voltage na, then which time power losses are high? During turn on of SCR means during rise time power losses are high. Okay, this about what exactly rise time. Concentrate on what is the definition, what is the observation, to protect that what you can do, but which is preferable. Both inductor and reactor is given, saturable reactor is given, your answer is saturable. The best answer is saturable reactor. Practically we prefer the saturable reactor. Clear? Practically what you can do means, we can do like this. Inductor means a thyristor is connected in series with inductor. Saturable reactor is represented like this. This is saturable reactor. This inductor is connected in series with SCR. Saturable reactor is connected in series with SCR to protect from sudden change of dIGBT. Okay, this about what exactly rise time. Then last one is what exactly a spread time, that you concentrate. What is the spread time? Okay, what is the spread time? How to define spread time? It is a time between 90% of IA to 100% of IA, or it is a time between 10% of EA to on state voltage drop. On state voltage drop means when the SCR starts the conduction, there exists some voltage drop across the SCR na, that is nothing but on state voltage drop or forward voltage drop. Okay, then you define spread time. What is the spread time? Yes, a spread time. This last one, a spread time TS. That is, it is time between 90% IA to 100% IA. That is 100% IA, or it is time between 10% VA to on state voltage drop. That means during rise time the current will be spread throughout the SCR. Then voltage falls to on state voltage drop, forward voltage drop. If any device is conducting, there is some voltage drop across the device now, that is nothing but a voltage drop, forward voltage. This is about what exactly turn on time characteristics. But I want to explain based on this how this turn on time will depends on the various parameters. Here I given just what is the delay time, what is the rest time, what is the spread time, what is the significance of all these time I explained. Then the continuation of this concept is how this turn on time will depends on the various parameters. Then we go for the what exactly turn off characteristics of SCR, and what is the significance of the turn off characteristics also I want to explain. That you will see in the next session.